Welcome to Study Loop.
Hello everyone, this is the solution to problem 46 of chapter 24 of college physics. Here we're told that we're given two pairs of polarizing sunglasses, and we're asked to devise some experiments that are going to allow us to test various properties of light. So already the very first experiment that you can design is kind of obvious in the sense that you have two polarizers essentially. So what you can do is you can test the polarization of light straight away. So what can you do? You can get some kind of light source and you can set up the sunglasses as shown in this figure such that the lenses are perpendicular to each other, in which case this essentially translates into an incoming light wave incident on a polarizer that has some polarization axis like this. And then the transmitted wave, let's say that this is the incoming wave is polarized in some direction. Then after it passes through this polarizer, it's going to be polarized in the direction of the polarization axis of the first pair of sunglasses. And then it's incident on the second pair of sunglasses, which has a polarization direction perpendicular to the first one. So if this is, let's say this is at 90 degrees and this is at 0 degrees, then the angle of difference between the polarization axis of the second polarizer and the polarization axis of the wave coming out of the first polarizer is 90 degrees, meaning that you get no light coming through. So this is one thing that you can do, for example, and then you can play around with this by rotating the second pair of glasses and then jotting down what the various intensities are at the very end. So you're essentially trying to test what kind of relationship you can get out here. And in order to test whether your experiment is reproducing what you expected, you can devise, for example, this prediction. You can say that the final polarization or the final intensity is going to be the incident intensity times cosine squared of theta. And then you can just make various predictions based on what kind of light source you got, for example. The easiest one is if you had an unpolarized light source. So let's say that you had no polarization, then you would just have some random intensity, I0, coming in here. But you know that the intensity coming out in the middle is always going to be I0 over 2. So this is what your incident intensity in the second polarizer would always be. So this the first experiment, you get some unpolarized light source, you shine it through the first pair of sunglasses, and then you rotate the second pair around 360 degrees to see where you get maxima and minima and what kind of intensities you capture. Okay. Second experiment that you can do is testing, for example, the Brewster angle of some, again, it can be an unpolarized light source, and you shine it on some medium, which is this. I just represented this with some glass pane over here. And then if you hit the correct angle here, which is the Brewster angle, so if this is theta p, or it's also known as the polarization angle, then the wave reflected is going to be polarized. Now, if you do this, then the polarization direction is going to be perpendicular or parallel to the surface of the object that you're reflecting the wave from. So it's going to be polarized in this way, schematically. And if that's true, then if your sunglasses are polarized as they were up here, so in the horizontal direction, so like this, then if you placed this laser beam at the Brewster angle of the material that you're reflecting off of, then you would see that there is no light being reflected, or there is, but you wouldn't see it because your glasses would block them out completely. So this is another experiment that you can do. And again, here the prediction is that you would know at what angle you would have to shine this light onto the surface based on the material of the surface in order to produce this polarized light. And if you are looking at this reflection at the right angle, then you would predict that there would be no light. There would be no intensity coming through the sunglasses into your